Okay, hello everyone, it's Salar and we are in part 61 of our tutorial, a tutorial to writing a real-time operating system. In this part, I want to start to talk about MemPool. MemPool is a memory allocator mechanism that's implemented in RTOS, like malloc implemented in neolib library. But MemPool has been implemented in RTOS. In this part, I want to start to talk about MemPool. But what is MemPool and why do we need to use MemPool? To answer this question, why do we need to use MemPool? Let's see some information and let's see some problems of malloc and free functions. Okay, first. Now I'm gonna describe what is fragmentation in heap memory. Okay, what's fragmentation in heap memory? To describe fragmentation, see this slide. Assume this is your heap memory. Okay, this is your heap memory, and you have 4 allocated blocks in your heap memory, blocks 0, 1, 2, 3. Okay, and in this memory allocations, you have 2 small blocks. One of them is 4 bytes and another is 8 bytes. Okay, as your block 1 size is 4 bytes and block 3 size is 8 bytes. And in your code, you free these 2 blocks. Okay, you free these 2 blocks. Now you have a 4 byte free block and an 8 byte free block. The total size is 4 plus 8, 12 bytes. You have 12 free bytes in your heap memory, but these 2 blocks are not continuous. Okay, now assume you want to allocate a 10 byte block. Okay, a 10 byte block. The maximum size of free blocks are 12. 12 is greater than 10 bytes, but these blocks are not continuous. Because they are not continuous, you can't allocate a 10 byte block size. Now, spreading a small heap blocks in heap memory. Spreading a small 4 byte and 8 byte. For example, blocks in heap memory makes the heap memory almost unusable, not completely unusable. Okay, for example, at this time you can allocate a 6 byte memory. Okay, but you can't allocate, for example, 10 bytes. Okay, almost unusable. This problem called heap fragmentation. Heap fragmentation is one of the heap problems. Okay, but there is another problem. There is another problem in heap memory. In using of heap memory, you can't call malloc and free functions from interrupt, because malloc, for example, call malloc lock and malloc unlock, as I said in previous part. Okay, malloc function calls malloc lock and malloc unlock in its process, and malloc lock and malloc unlock implemented by using of mutex, and you can use mutex APIs from interrupt. So you can't use malloc function from interrupt. You can't use malloc function from interrupt. Okay, so we have 2 problems in heap memory. First, fragmentation. The next, you can't call malloc from interrupt. Because of these problems, we implemented MemPool. We have implemented MemPool in our real-time operating system. It's a memory allocator, dynamic memory allocator, okay? But what is MemPool and what is the structure of MemPool? MemPool is a memory allocation mechanism like malloc that implemented in RTOS, not in library, okay? Implemented in RTOS and gives constant size blocks to the user and can be called from interrupt. What is constant size? Here is a structure of MemPool. When you want to create a MemPool in the real-time operating system, in our real-time operating system, you can use this function, MemPool create new. This function needs 3 arguments. The name, the string, block size, and number of blocks. For example, assume here is a MemPool. Okay, assume here is MemPool. We have, for example, 8 blocks, block 0 to block 7. 8 blocks in our MemPool, created MemPool. And size of each blocks, for example, block 1 is 32 bytes. Okay, size of each blocks is 32 bytes. When you want to allocate memory from MemPool from one of created MemPool, you can use this function, this API, MemPool allocate. You must give the ID of the MemPool that you want, for example here ID of this MemPool, and a timeout. I will talk about timeout in next part. And this function returns an address of one of these blocks, block 0 to block 7. One of 3 blocks. For example, when this function wants to return the address of block 1, return address of this point, start of this block. Now you have a 32 byte block, okay, and you can use the 32 block in your code, okay. So the size of block is constant, gives constant size blocks. But because the size of allocated blocks in a heap memory is constant, size of allocated memory in a MemPool is constant, you will not have memory fragmentation in MemPool, okay? You don't have fragmentation in heap, in MemPool you don't have, because size of all of allocated blocks is constant, okay. And by using of MemPool free API, you can return and deallocate the allocated block. You can return the block to the RTOS, like free in malloc and free functions. But since the block sizes are constant, we will not have fragmentation, okay? Because of this reason, we will not have fragmentation. But as the size of blocks are constant, size of block is constant, if you need a memory space smaller than block size, for example, assume you have in this example size of blocks are 32 bytes, but assume you need just 20 bytes, and 20 bytes is smaller than 32 bytes, okay? If you need a memory space smaller than block size, you will waste some memory in block. For example, in this example, you will waste 12 bytes 32 minus 20 equal to 12 bytes. This is one of the MemPool problems. Okay. Sometimes this problem called internal defragmentation. Okay. Internal defragmentation. Internal fragmentation. What is internal fragmentation? In this example, when you need a memory size that is smaller than block size, you waste some memory in your heap. For example, at this time 12 bytes. This wasting memory called internal fragmentation. But wasting memory outside of a block. Okay, for example, here is a block and here is outside of a block. Okay, this fragmentation called external fragmentation. Okay, so when you waste memory inside of block in MemPool, this is called internal fragmentation. When you waste memory outside of a block, for example in heap memory, this is called external fragmentation. But internal fragmentation and external fragmentation mostly used in those systems that has MMU, memory management unit. Okay, these terms mostly used in those systems that have memory management unit. But the concept of internal fragmentation and external fragmentation is unique. So, what is MemPool? The memory allocator mechanism. Why do we need to use MemPool? Because we have two problems in heap memory and malloc functions. First problem of malloc is external defragmentation. And the second problem is you can't call malloc function from interrupt. By using of MemPool, you can get rid of these problems. Okay, thank you very much to see me, and in the next part I will implement MemPool in our real-time operating system.